Ugh, Mrs. Curtin, there must be an easier way to do polynomial long division. Well, students, in fact, there is. It's called synthetic division, and it's super awesome. Okay, suppose we have a long polynomial, and it is 3x cubed minus 5x squared minus x minus 2, and it's divided by x minus 4. How can I do this in an easier manner? Well, what I might do is start off by saying, what's going to make the bottom thing 0? Well, what makes x minus 4 0? It's going to be 4, right? So what I'm going to do is I'm going to take that thing that I'm dividing by, right? Whatever makes it 0, I'm going to put it on the outside, and then I'm going to make this little L shape. And then what I'm going to do is I'm going to fill it with the coefficients of my polynomial. So I have 3, -5, 1, right, and -2. And what I'm always going to do is it's going to be in kind of descending order, right? So I have x cubed slot, x squared slot, x slot, and then x to the 0 slot. First thing I do is bring down the 3, then I multiply 4 times 3, which is 12. Then I add -5 and 12, which is going to be 7. Then I multiply 4 times 7, which is 28. Then I add again, which is going to be 29. Then I multiply, which ends up being, 116. Yes, I did that in my head. Just kidding. And then we do -2 plus 116, which is 114. Okay, I'm going to draw a dotted line there because whatever comes last is the remainder. Anyway, so I've divided by an x term, so my degree of my polynomial answer is now 1 degree lower, so it's going to start with x squared. So I'm going to have 3x squared plus 7x plus 29 plus 114, I wrote that wrong, and then over, right, the thing that I was originally dividing by, which was x minus 4. So that's how we do synthetic division. Anyway, we're going to do another example, so don't worry if you don't have it yet. Anyway, so I'm going to have this polynomial on the top. I'm dividing by y plus 2. So what makes y plus 2 0? Well, -2. So I'm going to put that on the outside of my box. I'm going to draw my L shape, and then I'm going to take the coefficients, right? So I'm going to first mark out what my slots are, y to the 4th, y cubed, y squared, y to the 1, y to the 0. Whew. And then I'm going to take the coefficients, right? I have 1, and then I don't have a y cubed, so I'm going to put a 0 there as a placeholder. And then I have -4, 1, and then 4. So I bring down first, bring down the 1, then I multiply, which is -2. Then I add, which is -2. Then I multiply, which is 4. Then I add, which is going to be 0, and then I multiply, which is 0, 1 plus 0 is 1, and then -2 times 1 is -2, and then 4 times -2 is 2. So I end up with a polynomial answer, which is 1 degree lower, right? So I get y cubed minus 2y squared plus 1, and then plus 2 over what I was originally dividing by, which was y plus 2. Let's do another example in case you don't have it yet. Anyway, we're just always multiplying and dividing. Adding and multiplying, adding and multiplying, adding and multiplying, over and over again. Now, this is kind of a tricky situation. What if I have like a 3 in front of my t? Okay, well, I have to do something first before I do that. What I'm going to do is I'm going to factor out 3, and I'm going to be left with t minus 2/3. Okay, and I'm actually going to synthetically divide by what makes that 0, which is 2/3. Right, so I'm going to take 2/3 and synthetically divide my polynomial by 2/3. So I put my coefficients. I have 6, 5. I don't have a t squared term, so I'm going to put a 0, and then I have -10 and 4. So I bring down the 6, and then I multiply, which is going to be 4, and then I add, which is 9, and then I multiply again, which is going to be 6. I add, and that's 6. I multiply again, and it's 4. I add, and it's -6. I multiply again, it's -4. I add, and that's 0. Okay, so I have 0 remainder, and my new polynomial is 1 degree lower, so it's 6t cubed plus 9t squared plus 6t minus 6. But remember that I factored out a 3 at the beginning, so this is still over 3. So my final answer is I actually just divide all of those by 3, and then I get this polynomial as my final answer. And that is how we do synthetic division. Okay, let's go ahead and take another example. Let's suppose I have z cubed plus 3z squared minus 2z plus 3. Now this is going to be divided by z minus I. Okay, well, what makes that 0? It's just I, right? I minus I is 0. Okay, so I'm going to put I on the outside, and I'm going to have my coefficients as normal, 1, 3, -2, and 3. I bring down the 1, and that's 1. I multiply I times 1 is I. And then I add, but I have to keep those separate because they're not like terms, right? I have to keep 3 and I separate, so it's just 3 plus I. And then I distribute the I when I multiply, so I get 3i plus I squared, right? And when I add that, because I squared is -1, -2 plus -1 is just -3, and then I distribute again, I get 3i squared minus 3i, right? 3i squared is just -3, so then I end up with a remainder of just -3i when I add the 3 and the -3, they cancel. Okay, so then my final answer for my polynomial is z squared plus 3 plus I z plus -3 plus 3i plus -3i over z minus I. You don't have to worry about the I on the bottom of that fraction, even though you usually do. In this chapter, for some reason, you don't. Anyway, good luck on your homework and have a great day.